In this video, we continue in Chapter 12 about chemical bonding, and we're at the point where we're going to talk about covalent bonding. So covalent bonding, if you recall, is the bonding that forms between nonmetals. And in covalent bonding, the electrons, specifically the valence electrons, are shared. So just to review, we've talked about ionic and now covalent bonding. Ionic bonding is between metals and nonmetals, and the electrons are transferred, or another way to say that is they're lost and gained. That creates charge or ions, and the ions are attracted to each other. That forms the ionic bond. In covalent bonding, there's some differences. One is that it's with nonmetals, like I just mentioned. And the valence electrons are still involved, but now the electrons are shared. So we're just going to spend a little bit of time in this video thinking about how we can imagine the sharing of electrons. So the sharing of electrons results in covalent bonds. And the formation of covalent bonds results in a molecule. And recall, a molecule is just an individual unit of the atoms. This is in contrast to the crystal array or crystal lattice structure formed by the ionic compounds. So in this illustration, and there's one on the next slide too, I'm not going to ask you to redraw this. I myself appreciate when my imagination can connect with the words that are being said. So on the left here, we have hydrogen atoms. You see in this little diagram, those are the little dot structure. If I enlarge it, it's hydrogen with its one valence electron. And I'm going to put mine on the other side. Now, hydrogen has a 1s orbital, so that's what this is representing. Now, what we can imagine is that to share the electron, this and this hydrogen would come together. And so then what you see is that hydrogen, each one would now have a pair of electrons, and we call that a shared pair. A shared pair of electrons is called a single covalent bond. Now, hydrogen is very happy with just sharing 2 electrons, and the neat thing about covalent bonding is when they share, this hydrogen right here is satisfied with its 2. Now, we talk about the octet rule, which is 8, but hydrogen, remember, is in the first period, which represents just having a 1s sublevel, which means there's just a 1s orbital. So there's no space for more than 2 electrons. So hydrogen is satisfied with 2. It doesn't have to have the 8 like the other nonmetals. So back to my hydrogens. The hydrogen circled in pink is happy, and now the hydrogen circled in green is happy. So when they share, both atoms see this pair of electrons that's in between as their own, and so they feel like they have the same electron configuration as a noble gas. Now this illustration on top, the tealish cloud, that's how we would imagine the 2s orbitals here overlapping. And so here the nuclei would be here, and they're overlapping the electron cloud. So that's trying to show it overlapping. Okay. Again, I'm not going to ask you to draw that. And you might in the future classes, you might draw these things. But I just want us to start thinking in our mind how we might imagine the overlapping of orbitals. Now on this slide, it's the p orbitals that we're imagining overlapping. And so they draw on the top the p orbitals, which look kind of like dumbbells. Now, remember that there's 3 different p orbitals. So this is just one from each chlorine atom. And then here is where they show the 2 overlapping p orbitals, and that's where the covalent bond would be. If you look down at this section here, and I'm going to write it larger. So chlorine has 7 valence electrons. So the idea would be that if these 2 chlorines came together, their single electrons would then make a double one for the chlorine. So now if the chlorine on the left looks, okay, it sees 8, right? And that's stable. The idea of the octet rule, part of it was that the electrons would be shared so that an atom has 8 electrons. And specifically the valence electrons, I keep just saying electrons, but it's specific to the valence electrons. And then this chlorine also sees 8, and that is the result of this is a shared pair. That's a single, represents a single covalent bond there between the 2 chlorine atoms. And so let's look at a little bit of the words that we use for the octet rule in covalent bonding. I already mentioned it. We've mentioned the octet rule multiple times, and in the octet rule it says atoms will lose, gain, or share. And the losing and gaining are ionic bonds, and now the sharing is covalent bonds. So they're going to share, and that's valence electrons. And again, in octet rule, so that they have the electron configuration of the noble gas that's closest to them. They like the noble gases because they have a complete valence shell, and that's very stable. And we think of it as the number 8 because that's what the complete valence shell is. Now, so the main group elements want to have 8, but hydrogen can only have 2. Maybe I'll make that in a different color. So hydrogen can only have 2. So when we talk about the octet, a lot of times I'll say except for hydrogen. That's because hydrogen can only have 2, but the other main group elements are going to want 8. Now, in this introductory course, I'm going to tell you that some nonmetals can have more than 8 electrons around them, especially when you get past the 3rd period. So some can have more. It's called an expanded octet. What I'm saying, I know you can't see my lips. Expanded octet. But for our class, as we're just learning about the octet rule and Lewis structures, I want you to be aware of the existence of the expanded octet, but we are going to put our focus on atoms that fulfill the octet rule. So let's look at this example that's written with the Lewis dot structures. So if you can imagine on the left, there's a hydrogen with 1 valence electron and a fluorine that has 7. And so these 2 things are coming together. And when they come together, it looks like this. Now so hydrogen, I want to draw it like this. Hydrogen looks out and sees 2 electrons from that sharing, and so it feels like it's satisfied and stable. And the fluorine looks around it, and it also looks at 8, so it also thinks it's stable. And it's this pair in the middle that is the single covalent bond, and it is being shared. Now, in the next picture here, then you'll notice that in this one, they don't draw the dots for the bond. They draw a line This is what I tend to do. That line represents 2 electrons shared. And we call that a single covalent bond, or sometimes we just say single bond, okay? Then the electrons around the fluorine that are not being shared are called lone pairs. You can see down here at the bottom, sometimes they're called non-bonding pairs. So there are going to be on our structures electrons that make an atom have 8. So they're there with the fluorine. The fluorine has 8, but they are not participating in the bonding. And we call those lone pairs or non-bonding electrons. Now, we won't just have single bonds once we get going. So you can have a single line. This equals 2 electrons being shared, and it's called a single bond. And it's a single covalent bond, but I don't have enough room. You could also see a double line. Okay, this is 4 electrons being shared. So this is how we're going to draw shared electrons as a line between atoms. This is called a double bond. And then finally, we could have 3 lines. So each line represents 2 electrons being shared. And so 3 lines represents 6 shared electrons, and this is called a triple bond. So we'll be using lines for the shared electrons, and then we'll be using the dots for the non-bonding, or also called lone pair electrons. So in the next video, we're going to learn how to draw something called Lewis structures, and we can get quite a bit of information from our Lewis structures.